I thought I'd walk and talk about mathematics. They did this conference of experts in 2012 in Berlin, and on paradox and reform in logic. It looked quite interesting. And I mentioned to Thomas Forster about I've forgotten his name now. Priest. His talk about logic. Graham Priest, and the problem that I had in 2009 when I tried to reform logic was that I wasn't an expert. I wasn't an expert model theorist, and I wasn't an expert proof theorist. And I thought it would be possible to talk to people who were, to get different angles on things, and I thought that the way to do that would be to start with a very simple example of something and talk about what the problems were, because that example that I produced actually just came from an exercise. I was trying to write a very low-level introduction to lambda calculus without fixed point combinators or anything fancy like that. And I wanted to show a problem and I found that by introducing this rule, I started with just using the idea of abstracting certain types of structure that were presumably common patterns, and then using lambda notation to write down expressions which consisted of compositions of other expressions that you'd produced up to that point. So it was an enumeration exercise of sorts, but I didn't write down any, at that stage I hadn't thought about any particular enumeration. I simply thought about how would you explain to somebody that this notion of structure just by substituting in variables, substituting arguments into bound variables, would produce a kind of efficient description of a system. If you think about science, the generalizations that people do in physics, or when you describe a physical experiment in a laboratory, you describe it in terms of an abstract laboratory. It's one that any other physicist who has the wherewithal and understands your description can put together his particular instance of that abstract laboratory. And unless you've made a mistake, or unless there are no laws of physics, you will be able to reproduce the phenomena, but you won't reproduce exactly the phenomena that occurred in the original laboratory, because you won't have exactly the same laboratory. But what you want to capture in the physical theory is the fact that there's a formal structure, and you want to cause the effect that you're describing. And that's the kind of causality that's important in physics. And that's the kind of determinism that you need in physics. But when Sabine Hossenfelder talks about determinism in physics on her walking, talking videos, she doesn't think about that. She, in common with a lot of physicists, I suppose, she thinks of the determinism acting at the level of particular individual instances. And then she loses me, because you don't have control over whatever people at CERN might say. You don't have control over individual muons or these things they study. You abstract those entities from macroscopic variables which you do control and which you can determine, and they are things like the magnetic fields and the energy of the beam and stuff like this. But the determinism I don't know what they all sound mad to me. It's all absolute madness. People who think that the world is caused by particles bumping into each other have lost the plot completely. Because that kind of description is useless. And that Pollock, I've forgotten his name now. Is he Graham as well? Andrew? Anyway, that thing on exclusion zone water and the chemistry of water is really, really good. And it just shows how completely this reductionist physics has dominated things like meteorology, to the point where they've actually missed a huge swathe of phenomena, and they put all this stuff into their Navier-Stokes equations and tried to predict the weather using basically finite element analysis on compressible fluids. But they threw out a whole lot of obviously causal components in their model, and I guess because the model produced the phenomena that they were studying in some degree, they thought that they'd captured the essence of the weather. But it's pretty damn clear that they've missed this whole electrical charge component. Nobody's measuring that. There's no data. And that's because they were convinced that physical laws were reductionist, that you could deduce the behavior of sky and ground and water and clouds from assumptions about ideal gases or something. And that's the source of all the madness. So that's what I think, Sabina. I hope you enjoyed your walk as much as I did.